This video presents perspective projection. Our last videos discussed parallel projection of various types, including axonometric and oblique projections, as well as the special case of orthographic projection, such as plans, sections, and elevations. All of these earlier types share one important property: projection rays that are parallel with one another. We've also found that the projection rays have been perpendicular to the draw plane, except for the unique case of oblique projection. In perspective projection, we'll find that neither one of these properties holds true. When constructing a perspective, projection lines are not drawn relative to the draw plane, but rather a station point or camera position. The resulting rays are then intersected with the draw plane to produce the resulting drawing. The effect of this is that the relationship between station point, draw plane, and the drawn object begins to have an effect on the drawing result, much more so than it did in parallel projection. For example, if we were to move the station point forward, but keep the relationship between the station point and the draw plane fixed, then that would have the effect of seemingly walking forward in the space of the drawing, or moving into the space in question. In contrast, if we were to allow our station point to remain fixed in space, but adjust the relationship between the draw plane and our station point, then that would have the effect of enlarging or reducing the drawing on our paper, but the drawing itself would remain geometrically the same. One important property of perspectives, which differentiates them from other types of parallel projection, is that parallel lines in the object depicted are not parallel in the drawing, but rather converge at some infinite distance. Typically this is drawn as a vanishing point on the horizon, whereby any collection of parallel lines would converge. With this understanding, we can begin to distinguish between types of perspective drawings, given by the number of vanishing points that they contain. So there are one-point perspective drawings where all lines are either horizontal, vertical, or converge to a single point, and there are two-point perspective drawings whereby all lines are either vertical or converge to one of 2 points, and there are even three-point perspective drawings whereby all lines converge to one of 3 points. Now, it should be noted that all three of these types are based upon a kind of assumption of a Cartesian overlay upon the world, whereby lines can only exist at 0, 90, or 180 degrees, which, of course, as we understand today, is not always the case. So that's it, a quick rundown of perspective projection. Hope it's been helpful.